Hey, folks. Hey, your teacher's on a roll. I am now making like my sixth or seventh video today. I'm real proud of myself. All right, so don't tell me you've got to work too hard because so am I. Oh, I'm not complaining. All right. No, I'm going to cough again. Never mind. Okay, so the next section's on volumes. Volumes. And you've got the formula for volumes. You were sent those. I'll probably send those again today, just in case you've lost them. Anyway, the formula for volumes. If you're doing it basically like a box, it's basically the length times the width times the height. So if you have this is your length, this is your width, this is your height, it's the length times the width times the height. It's no big deal. All right. So there's a few that are a little bit probably new to you. A cylinder is one your author likes to use a lot. So you need to be familiar with that. When it says it's a cylinder, just think it's a can. It's a can. And so if you're looking for the volume of a can, it is pi r squared times the height. It's basically the area of the base times the height. So if I'm looking at a can, like a can of string beans or something, how much does it hold? It's the area of the base times the height. If I'm looking at a sphere, sphere is one that's a little weird to some of you, you've never done it before. A sphere is a ball or a globe, and its volume is 4/3 pi r cubed, r to the third power, where r is the radius. And so the example I always used in class when I did that is if I'm buying a balloon, if I'm buying the 10-inch balloons, how much helium does it take to fill the balloon? So if it's a 10-inch balloon, 4/3 pi r cubed would be 4/3 times pi, and r would be 5 because the radius is half of the diameter, and they sell balloons by their diameters. So I would take my calculator and just go 4 divided by 3 times pi times 5 to the third power. If you put that into your calculator, you should get that it's 523.6 cubic inches. They'll call that inches to the third power of helium in each of the balloons. So that's one of the things they have. Another thing they have is basically cones and pyramids. If you're dealing with anything that's cone shaped or a pyramid shaped, okay, if you're dealing anything that's coned or pyramid, your volume will be 1/3 times the area of the base times the height. So if your base is a circle, it'd be pi r squared times the height, and then it would be 1/3 of that. If your base is a square, it would be the side squared times the height, and it would be 1/3 of that. So that's some of the things you'll see in that section. And then for real world applications, I'm going to do a couple. I'm a big fan of my swimming pool in the summer, and I use pool noodles a lot. And I'm sure you're familiar with pool noodles. Pool noodles are basically made of foam, and they have usually a hole that goes down the center all the way. So I wanted to know how much volume of foam does it take to make a pool noodle. I'd start out by going the length of my pool noodle. Pool noodle is, let's say, 6 feet, and which, by the way, is 72 inches. Okay, so I'm going to do it in inches. And then at the end of my pool noodle, the circle on the outside is about, it's probably about 5 inches. And the circle on the inside is probably, let's say, 1.5 inches. And that's diameter. All right, so if I want to know how much area does my pool noodle need, or volume does my pool noodle need, in terms of foam, it would be pi r squared h for the entire noodle, which would be pi times 5 inches, which means it's 2.5 is the diameter, squared times the height of the noodle is 72 inches. And that would be the entire noodle. So then the empty hole in the middle would be 1.5 divided by 2, which would be 1.5 divided by 2, which would be 0.75 squared, pi times 0.75 squared times 72 inches. So that would be the empty hole. And so I need to do those calculations. So the big one up here, the pi times the 2.5 squared times the height, which is 72, that gives me 1,413.7 cubic inches. Cubic inches, because these are inches, and I'm squaring them, and these are inches, so I end up with cubic inches. And then the smaller part of the noodle, the hole that's cut out of the middle, would be pi times 0.75 squared times 72, and that would be 127.2 inches cubed. And I'm going to go back a little bit and make sure you understand where the 2.5 and the 0.75 came from. The 2.5 came from the fact that it's 5 inches divided by 2 is 2.5 for the radius. And the 0.75 came from 1.5 divided by 2, which is 0.75 for the radius. So if I want to know how much does it take to make a noodle, then I take 1413.7 minus 127.2, and that gives me 1286.5 inches cubed of foam for each noodle. So if I'm a noodle company, that's how I have to calculate how much foam do I need to make my noodles. All right, does that make sense? I hope it does. All right, so that's that video. I'm going to stop.